This is Precalculus section 1.8 day 1 notes. Today we're going to have a little bit of a review of coordinate geometry. This basically two number lines intersecting in front of you here, which we know as the x-axis and the y-axis, is called the coordinate plane. You may also hear it sometimes called the Cartesian coordinate plane. I never say that though, I just call it the coordinate plane. So in the coordinate plane, a couple of points of interest here. Obviously, this center 0, 0 is referred to as the origin. And then we have the four quadrants, which are labeled 1, 2, 3, and 4 using Roman numerals, and they start in the upper right-hand corner and go counterclockwise. Example 1 asks us to graph the line y equals 4 in the coordinate plane. Okay, so now this right here means in coordinate plane, which tells us that this is going to be a constant function, and in this case it's a horizontal line. So we just go up to y equals 4. If this is 0, 0, we count up 4, and there's our line y equals 4. The next one again asks us to graph an inequality of lines. So again, now because they're x, these are going to be vertical lines. And since this is an inequality, we have to pay attention to the fact that our symbols do not have the line underneath. So when we draw these vertical lines at x equals -1 and x equals +2, we need to make them dashed. Remember that if these two symbols mean we draw our lines dashed, and these two symbols mean that we draw our lines solid in the coordinate plane. So there is x equals -1. And here is x equals +2. And if x lives somewhere between those two, then we're going to shade the region between those two dashed lines. Next, we're going to talk about the distance formula. This is a bit of a review from geometry. The given 2 points A and B, the distance between them is found by distance from A to B is equal to, we've got a big square root, and then under the square root we subtract the x values and square them, and we subtract the y values and square them, and we add those two products together after we do the squaring, and then the last step is the square root. So to use the distance formula, we can solve the next example. It says, which of the points M or K is closer to A? Well, we can answer that question by finding the distance from M to A and finding the distance from K to A and seeing which one is shorter. Let's start with the distance from M to A. This is x, y, and xy. Okay, so I'm just going to use my points left to right in the distance formula. So my x values are going to be 3 minus 4 squared plus my y values are going to be -2 minus 2 squared. Simplifying underneath the radical first inside the parentheses, 3 minus 4 is -1. So we have -1 squared plus -2 minus 2 more is -4 squared. Now doing the squaring, -1 squared is 1, -4 squared is 16, and then finally 1 plus 16 is 17. And we can just leave our answer in radical form because we'll be able to compare distances in that form. Now we're going to do the same thing to find the distance from point K to point A. So the subtraction of our x values is going to be 7 minus 4 squared. Subtraction of our y's is going to be 5 minus 2 squared. So this gives us positive 3 squared and another positive 3 squared, which is 9 plus 9, which is the square root of 18. So the question is, which point is closer? Well, this distance is shorter, so M is closer to A. The midpoint formula is a formula for finding exactly what it sounds like, a point that is midway between two given points. So I like to think of a midpoint as an average point. And the formula for a midpoint is just finding an average. So when you find an average of two numbers, remember that you're adding two numbers together and dividing by 2 to find an average. So we are going to add our x's together and divide by 2, and we are going to add our y's together and divide by 2. And that's our midpoint formula. The most common error that students make is confusing the signs in the distance formula and the midpoint formula. So please try to remember that the distance formula has subtraction, whereas the midpoint formula has addition. So for our example, let's find the midpoint of the segment that joins L and P. So our midpoint of LP is going to be equal to our x values added, 3 plus -1, and divided by 2, and our y values added, 5 plus 11, divided by 2. 3 plus -1 is 2, 5 plus 11 is 16, and then finally 2 divided by 2 is 1, and 16 divided by 2 is 8. So our midpoint is the point 1, 8. The Pythagorean Theorem. So here's our triangle, and this is a right triangle. That's important. We will call the legs A and B, and we will call the hypotenuse C. The Pythagorean Theorem says, if triangle ABC is a right triangle with legs A and B, and hypotenuse C, then A squared plus B squared equals C squared. The converse of the Pythagorean Theorem then says that if triangle ABC has side lengths such that A squared plus B squared equals C squared, then triangle ABC is a right triangle. Typically, we're using the Pythagorean theorem as A squared plus B squared equals C squared. We're not typically using it to prove that we have a right triangle, but that is a valid way that we can use it. We can use the converse just as easily as we can use the original. And that's just what we're going to do in our example. It says, show that the triangle with the vertices Q, L, and G is a right triangle using the converse of the Pythagorean theorem. So we have a little graph here where we can make a picture. And so if we just quickly plot our points, Q is 2, 2. L is 3, -1. And G is -3, -3. So these 3 points form a triangle. And we are asked to prove that this triangle is a right triangle using the converse of the Pythagorean theorem. So basically, we are just going to use the distance formula to find the lengths of the three sides of this triangle and then decide if a squared plus b squared equals c squared. So first, let's find the distance from Q to L using the distance formula. This is going to be 2 minus 3 squared plus 2 minus negative 1 squared, chop, chop. 2 minus 3 squared. 2 minus 3 is negative 1. Negative 1 squared is 1. 2 plus 1 is 3. 3 squared is 9. And then 1 plus 9 is 10. So the distance from Q to L is the square root of 10. And again, we are just going to leave that in radical form. Next, we're going to find the length of side LG. So this is going to be 3 minus negative 3 squared plus negative 1 minus negative 3 squared. Chop, 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 chop. So 3 plus 3 is 6. 6 squared is going to be 36. And negative 1 plus 3 is 2. 2 squared is 4. 36 plus 4 is 40. So the length of LG is the square root of 40. Finally, we have to find the length of side QG. So this is going to be 2 minus negative 3 squared plus 2 minus negative 3 squared. Chop, 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 chop. 2 plus 3 is 5. 5 squared is 25. So we've got 25 plus 25, which gives us the square root of 50. Okay, so now that we know that, remember the converse of the Pythagorean theorem says that if a squared plus b squared equals c squared, then a right triangle exists. Well, when you're looking at a triangle, remember that the lengths of the three sides, the longest side is always your hypotenuse. So if we look at the lengths of the three sides that we found, this side has to be C. And it doesn't matter whether we call QL A or B. So we'll call it A and we'll call LG B. So if this is true, then the square root of 10 squared plus the square root of 40 squared should equal the square root of 50 squared. Well, remember, when you square a square root, you just get that number. So 10 plus 40 equals 50. Yes, it's true. Therefore, this triangle is a right triangle by the converse of the Pythagorean theorem.